Gonna verbalize stuff, or can you send me stuff?
I already sent you some stuff.
Oh, okay. Let me pull it up here. Yeah, here it is. Looks like the place to start, huh?
From the last picture on there is the numbers of the homework assignment.
All right. Do you remember what they are? Which one should we start on?
I'm going to pull the picture now. 1 through 16.
Okay. If a circle is circumscribed about a polygon, then the polygon is what in the circle? There's circumscribed, and what other kind of scribed?
Inscribed?
Uh-huh. And it's either, in other words, if I draw a polygon, I can circumscribe it with a circle, which makes the polygon inscribed in the circle. I can also inscribe a circle, which makes the polygon circumscribed over the inner circle and inscribed over the outer circle.
All right.
Explain why the diagonals of a rectangle inscribed in a circle are diameters of a circle. Well, first of all, let's draw a rectangle, a circle. And let's make sure that it's not a square, because that wouldn't prove much. So why do those diagonals have to be diameters of the circle?
If the chords, if the corresponding chords are equidistant from the edges of the circle, yes.
In other words, what you mean is that that point to that point is the same as that point to that point is the same distance to that point and the same distance to that point. That makes all four of those lines radial lines. Each of those, that one, that one, that one, and that one must end up being a radius to the circle. And since they're back to back, it makes it a diameter. All right, number 3. It's angle A.
84 degrees.
What'd you say?
84 degrees.
No. Okay. If it comes from a central angle like that, then that's the same measure.
Yep.
That's not a central angle on number 3. In other words, on number 3, we're coming from the edge of the circumference. So what would your best guess be looking at that picture? Go ahead and make a good guess, because it's going to be correct. Is it bigger than 84 degrees or less than 84 degrees?
It looks like less.
Okay, by how much would you guess it would be less?
20 degrees about?
By half.
Oh.
Always think in terms of half or double when you're thinking in problems like this. In other words, if it comes from the central angle, it's equal to the central angle, but if it's caused by an angle formed by two chords, this angle is always half of that measure. Can you still hear me?
Hello?
Yeah, Cole, I lost you. Let me call you on my phone.
Hello.
I'm going to call you on my phone. Can you hear me?
Yeah, I can hear you now.
Okay. Yeah, I'm not sure how we were having audio before, but this works just fine, at least on my end. You can hear me fine? Let me turn my audio up just a little so I can hear you a little bit better. Okay, so there's really only two situations. There's the situation where an arc is formed by a central angle, and there's the situation where an arc is formed by an angle from the edge of the circumference. And one is equal and the other is half, and it's easy to figure out which. Just remember that one is equal and one is half. Okay. Hold on. So in number 4, they want the measure of angle G. What is the measure of the arc that is subtended by angle G? You know what that means?
What?
Subtended. In other words, when I drew my original, well, that angle theta subtends an arc that's also theta. When I say subtends, it cuts out that much of the arc. Okay? So what is the angle subtended by G? In other words, what's the arc measurement from F to D? It's the total measure of the circle.
Oh, 360.
So what's the measure of F to D?
190, so 360 minus 190.
Which is 170. So what's the measurement of angle G? Is it equal to 170 or is it half? It's one or the other.
I think it's half, right?
Correct. So it's 85. And always visually check it. Not that they're always going to draw these to scale, but usually they will. In other words, if we guessed 170, clearly that angle is not 170 degrees. So if it's either 170 or 85, you can figure out which. So you don't even have to memorize. You just know that the central angle is equal, the angle on the edge of the circumference is half. On number 5, let me think about 5 for a second. Okay.
Right, so...
It's angle N. Angle N is going to be what?
Oh, 20 degrees.
Well, that's arc LM.
Oh, 10 degrees.
10 degrees, exactly.
Okay, I forgot it was half.
Okay. Arc RS on number 6. From here,
67.
what?
It's double 67, right?
Correct. Okay.
So what?
Number 7. They want to know arc VU. And they're telling us that that's 30. That angle U is 30.
Okay, well, if you know angle U, then you can double that to get arc TV, and then you can subtract that from 180, which is the equivalent of the arc of a semicircle.
Perfect.
So
arc TV has got to be twice 30, or 60. And 180 minus 60 is 120. So the measurement of arc VU is 120. These are easy once you get the pattern down. Number 8. They want the measurement of arc WX. I'm sorry?
75 by 2. There you go. 260, which would leave you subtract that from 360.
Well, let's go back and look how you're doing this. Let's start with the angle they've given us, 75 degrees. What does that make arc WY?
WY would be 75 by 2.
Okay, give me that number. I mean, I appreciate you know how to do it, but let's put some numbers on there. What's 75 times 2?
150.
Okay. Now, we know arc WY, and we know arc YX. What is WX?
WX is 100.
Correct. Do they need you to do these error analysis problems also? Number 9?
Yes.
Okay. Describe the error in the diagram of circle C. Find 2 ways to correct the error. What's the error? Do it the same way you've done the last 4 problems.
Alright, so if you take angle Q, which is 45, times by 2 to get 90, you'd have 190 instead of 180, and it's a semicircle since the Q to R is a diameter.
Correct. So this, instead of 100, must be 90. Right? If it's 90 from R to S, then it's also 90 from S to Q, because that's a diameter. Okay. Name 2 pairs of congruent angles in number 10. Interesting. Ah, now I see. Now I see it. I didn't see it at first. What's congruent?
A and B, and then C and D.
Actually, not. Notice why those aren't necessarily congruent. They did not tell us that that was parallel to that. If they'd have said BC was parallel to AD, then you'd be right. But they don't, and they're not.
So it'd be B and D and A and C.
Look what happens to angle C. What arc does angle C subtend? What arc is subtended by angle C?
AB.
Okay. What arc is subtended by angle D, as in David?
AB, okay.
Same one. That means that angle is congruent with that angle. And going the other way, the arc that is subtended by angle B is CD. The arc that is subtended by angle A is CD. Therefore, those are also the same. And these lines don't have to be parallel. In other words, BC is not parallel to AD. It's all about if you have an angle that subtends the same arc, then they have to be the same angles. How about number 11? Use that principle on 11.
M and L
Are congruent
are congruent.
because
The same.
they subtend JK, exactly.
And J and K subtend M and L.
Exactly. That's a key thing in all of these problems. As they get harder, that principle comes up a lot. The arc that is subtended being the same for multiple angles. How about number 12?
X and Y subtend W and Z, and W and Z subtend X and Y.
Okay. Yeah. I'm not sure you stated it quite correctly. I would say X and Y subtend the arc WZ. And W and Z subtend the arc XY. I think that's what you meant. Okay. Oops, hold on. I'm having a hard time getting this thing in the picture here. What's going on? Oh, there, I got it. Find the value of the variables. Okay, I'm going to draw a picture of this one. You're going to use the same principles that we've been using. So this is 95, this is 80. Let's label them. Q, R, S, T. And that's the only labels we have, and we're trying to figure out X and Y. What's the arc subtended by the 95-degree angle?
RT.
Okay, so this one measured from there to there is what?
5 by 2.
190. Okay, what's the arc subtended by the 80-degree angle? Cole, still there? Gosh, lost it. Well, we are having a problem with the audio here, huh?
Yeah.
All right. Let's see. We got the arc subtended by the 95-degree angle. What's the arc subtended by the 80-degree angle?
QS. So with these, you just set 80x equal to 180 since corresponding angles inside of a circle. So instead of a circumscribed polygon inside of a circle equal 180.
Well, No? You know that x plus y is equal to 360 minus the sum of these two. Let's start with the information we have right now. What is the arc from R to there equal to?
Y times 2.
No? Well, okay. But what is it? We know the other half of it's 190, so what is this? It's got a total 360 around the whole circle.
170.
Okay, so if that arc is 170 and it is the arc subtended by angle y, notice that angle y, two endpoints go there. So what is angle y?
So y would be 85.
And now figuring out angle x is a piece of cake. We don't need to look at any arcs or anything. We just add up the three angles and subtract from 360 because we know a quadrilateral has to add to 360. So what does that give us? That gives us 90, I believe. So 90 and 80 is 170. 95 and 85 is 190. So that totals 360. Okay? So that's how you're going to do the rest of these. And unfortunately, I have a 3:30 that I have to go to. Cool. I'll talk to you next Monday.
Talk to you next Monday.
All right. Bye-bye.